It is the 8th of June 2025, and the Northern Hemisphere oceans have been warming up as summer starts off, and we're looking at the Eastern Pacific because here we've got multiple systems potentially developing. We've already had one, Alvin, and now it looks like we're going to have a couple more at least in the next week. Let's take a look at the National Hurricane Center. They have actually got 3 disturbances. The strongest chance of formation is on that one on the northwest side of the eastern area of convection, and then there's the second disturbance to 80% chance, and then we've got the disturbance more elongated to the southeast. On the satellite loop, those correspond to disturbance 1 with the greatest chance of formation, 100% in the National Hurricane Center. That's up here. Coast of Mexico is down here, Acapulco just in here. And then disturbance 2, this one off to the west. And then we've got our disorganized disturbance 3. Looking at the European Center surface winds, European Center model surface winds, we can see why disturbance 1 has that 100% chance of formation. It's pretty much almost there. Actually, the winds are slightly below tropical storm force at the moment at 30 knots, but they're very close. Perhaps it's there already. And then we've got disturbance 2, and that's over here. A bit weaker, a bit broader, but a larger circulation. Disturbance 3 doesn't look like much at all. So let's move this forward and take a look as to how this evolves. One thing is that disturbance 1 and 2, as they develop, they're going to be interacting with one another, possibly a little bit of Fujiwara action, which could introduce a bit of uncertainty into the direction of the forecast. It does look like the European Center is keen on disturbance 1 becoming the more significant of the 2 systems, but they end up in a kind of a tandem. But at this point, as we move forward into Tuesday, disturbance 1 has gone up and is entering cooler waters and is actually weaker than disturbance 2 by this point. Disturbance 2 has actually done a little bit of a Fujiwara job, hasn't it? It's kind of like spinning back around, it's stationary, and then moving back, and then it's taking up the space where disturbance 1 is now long dead and buried. And it also weakens as it moves over the cooler waters. Anyway, I wanted to go to Venturi Sky because I want to look back and see if some of these topographic corridors played a role in the formation of these circulations. To do that, we're going to go back in time to, let's go to yesterday. Take a look. Oh, that was, now they have it labeled 92E, 91E. Alright, so they probably shouldn't have these symbols indicating, it kind of gives the impression of them being tropical cyclones when they're not. Their disturbances. I mean, some people would say a tropical depression is a tropical cyclone. That is not what I was taught, but that's ooh la la. That's going to open a whole can of worms. But anyway, yeah, I can't actually see a big. Yeah, so I mean, there's definitely some coastal effects. There's a surge of what is that? East-southeasterly flow is clearly being affected by the Mexican coast. There's also this gap here, which is helping in that surge. That's an area where there is lower topography, I would presume. There's a lake there crossing this country here, which is, well, I don't know what country that is. It is Nicaragua, of course. We all knew that. This kind of shows it a bit better. So we saw that surge of winds, and you can see that there are these higher mountains that come down, but then there's this gap, and then there's the higher mountains in Costa Rica, Nicaragua with Lago de Nicaragua, indicating this gap in the mountain range, allowing that wind to cross across the isthmus, I guess you'd call it, from the Caribbean Sea into the Pacific Ocean, and allowing that wind to concentrate and surge. And then also those mountains here allowing the winds to also surge up. That, in general sense, if the winds are weak down here, that is a cyclonic vorticity generating system, simply because if you have strong winds on one side, it's creating a vortical or increased vorticity on the southern flank. hence the aiding of the development of the precursor systems. In general, this topography in the region of the far eastern Pacific is the reason why this is actually the highest density of tropical cyclone genesis in the world. In the world, Jeremy Clarkson. Let's check out the hurricane wharf. For anyone not familiar with this, this is a high resolution model which follows the storm. So we've got the low pressure center in the middle of this area domain where the high resolution is being output, and it will remain in the center because the domain is actually following it. So you'll see the coast of Mexico, which is up towards the right, that will move in position as the storm moves. So you see it moving away. So this initializes the storm as a very small circulation. This is disturbance 1, which is Invest 92E. Let's see how the hurricane wharf intensifies this storm. So long as it has anything in the greens, that indicates it's a tropical storm. So it's already a tropical storm by 12 UTC on Sunday, June 8th. It intensifies a little bit, becomes a strong tropical storm, seems to broaden its wind field as we move forward. Still a strong tropical storm by 9 UTC on Monday. As we move forward, it remains a decent tropical storm with a well-defined circulation that then weakens as it moves over the cooler waters. And I don't know what on earth is going on there, but something's gone horribly wrong. Oh, you know what? I think I know what's happened here. It's jumped to the other disturbance. The domain has actually shifted position to disturbance 2. So disturbance 1 has become so weak that it doesn't know where to find the center of the storm, so it jumps over to the other one. You can tell because the latitude in the first one is at 20 north, so disturbance 1 got to 20 north. We jump forward, it's down to 17, so that's disturbance 2. That's really interesting. I've actually never seen that happen before. Let's take a gander at how that MPI is doing in the Eastern Pacific. This is a measure of the maximum intensity possible in a region based on the environmental conditions and the sea surface temperatures, valid for the end of May. And it's all in the blues, dark blues, in the Eastern Pacific. But bear in mind, tropical cyclones rarely form towards the equator, equatorially of 10 degrees north. So this region is, even though the MPI may be high, there's just not enough spin really to get the tropical cyclones going. They do occasionally happen in towards the equator of 10 north or even 5 north, but anyway, so this would be, the genesis would typically be north of 10 degrees north, and that's what we're kind of seeing. And that's more rotation effect of the earth, allowing the storms to spin up. So there's a smaller region where the tropical cyclones can really intensify. Anyway, those blues are category 5 hurricane capable conditions. The problem is that there's very little time for the storm to intensify into that potential category 5 at the moment, because the cold waters begin very quickly. So as soon as the storms move out of this region into this region, they're pretty much done for. And we saw that with Alvin. It just completely lost all of its convection very quickly as it moved northwards towards Baja. So now the wind prediction really makes more sense just based on the energy available. We saw that high MPI that was to the east of Baja Peninsula, and it was really a sharp division. It kind of came down like this. So here, and then of course you've got, I don't know where 10 degrees north is, but anyway, 1005, whatever. It's down here. This is the less favorable latitudes down here. So let's watch this storm come up, strengthen over those high energy waters, and then as it moves forward over into the cooler waters, we begin to see it weaken and struggle, while the other one, maybe this line's not quite in the right place. You get the message. And then the other one comes up. It's also not particularly strong. So good news. At the moment, conditions are localized and really kind of compressed down towards the east. So this area There would have to be a storm that formed early, had chance to intensify, and then swung quickly into the coast for it to be a highly damaging hurricane at this point. But this is just the beginning. It's going to be a long season. The waters are warming, and we are going to see some big storms, some damaging storms. It's never pretty, but we'll be here for it. And I will see you in the next one.